Since the 16th century, the Netherlands has expanded its territory by some 8,000 square kilometers, an area around the size of Corsica.
We've always been threatened by water, by sea, by rivers, and we have defined a kind of mechanical, a kind of machine, what Holland is, an artificial country, where we can beat the water. We push the water out and we create a dry land.
Around 1/5 of the country is built on land reclaimed from the sea and the marshes. This reclamation is known as polderisation. The Romans used these techniques back in the 1st century. To polderize an area, it must first be dried out. To do this, it is surrounded by a dike. Then, with the help of windmills and now electric pumps, the water contained within the area is pumped out through canals. The water leaves behind muddy areas in which reeds or other plants are added to absorb the salt and complete the drying and desalination process. This marine land is thus transformed into arable land.
The decision to create these polders was connected actually by the projections of the demographics of the country, as well as the necessity to become independent in agricultural terms, to be self-sufficient agriculturally. So we needed new land, and we were very successful in doing so.
There are fields as far as the eye can see, covered with green grass. But behind this image of nature, each plot of land here is artificial. Under these carpets of grass, the earth lacks fertility.
Human beings have an amazing capacity to disrupt, but also to degrade and destroy entire ecosystems. You have to accept that in spite of our eco-engineering feats, no matter what we do, we'll probably never be able to create anything 100% natural.
Creating something 100% natural a fantasy? Not for the Dutch. The most incredible example of this artificial nature is the creation of Flevoland, an entire province in the suburbs of Amsterdam that is the same size as Luxembourg. Flevoland was created in 1986. It was a huge project that had been under consideration for decades and which met the Netherlands' constant need for more land for agriculture.
Between 1914 and 1918, there was a famine due to the First World War. This project came about to provide agricultural land.
This crazy project would never have seen the light of day without the enclosure dam completed in 1932. The dam created a lake, which allowed the Dutch to polderize areas of fresh water and thus create new land. But this reclaimed land is particularly vulnerable to flooding, and its inhabitants must live with that threat. The province of Flevoland is located at between 6 and 14 meters below sea level. The soil is fragile, and constant tides in the rivers make the risk of flooding a little greater every day.
Paradoxically, the cities most at risk are not exposed to the sea, but further inland. And then a city very much at risk is Lelystad, that actually is in a deep polder in an area that used to be part of the sea, but now is an inner lake thanks to a closure with a 30-kilometer long dike.
Lelystad is just 60 kilometers from Amsterdam, and the historic capital and the new city have something in common: the fragility of the soil. Amsterdam is located on swampy soil composed of soft peat and clay. This soil is a real challenge for architects. As far back as the 17th century, they had to find a way to make the foundations of the houses, designed in the typical Flemish style, hold firm in the ground. All buildings in Amsterdam are built on piles with wooden stakes. But to reach the first stable layer of solid sand, it was necessary to drill down to a depth of more than 11 meters, the equivalent of a 4-story building.
So every house you see, you have the house, you have the stilts underneath it, is put on stilts. And for example, if you go to the center of Amsterdam, there's a big palace. And underneath that palace, there is, I think, 13,000 piles of 20 meters holding up one building. So the most dense forest of Holland is underneath one building.
This underwater forest supports houses built on cob, a mixture of clay and straw. Designed to be submerged, this traditional material is very robust as long as it is not exposed to variations between air and water. But in recent years, traditional Amsterdam homes have been facing a new challenge brought about by global warming. This time, it is no longer flooding that threatens them. It's drought, which poses a danger to their foundations. This is a new phenomenon for this northern European capital. In recent years, the city has experienced long periods of drought and heat that make the water levels in the canals fall, exposing the cob to the open air, making it dry out and crumble. Then, when the water rises during the winter, it seeps in and eats away at the foundations. The historic centre of Amsterdam is now facing a new risk, that of collapse.
Holland is artificial, it's fake, and the people at the water board, they can manage to bring water up and down. Same if you're a DJ, you can also tune the music and make the rhythm and the sound and the light go. That's how we also work with Holland. So if we have water storage areas, then if there's too much water, we bring the water to the water storage area, and by that the water level in Amsterdam stays the same. If there's a lot of dry, we bring water from the water storage areas back into the water. So then still we have the same level. So the challenge is how to keep your water level always stable.
Controlling the water, monitoring the level, and keeping it at a distance so it doesn't engulf the country. The Dutch have been fighting against water for centuries. But there is one danger that nobody can be fully protected against: storms. Winters in the Netherlands always bring storms. The combination of very high winds and the North Sea at its highest level brings a real threat of flooding. The fear of seeing waves of icy, muddy water breaking on the coast is in everyone's minds. Every year behind the dykes, they prepare themselves for the worst. And the worst happened to the Dutch on the night of the 31st of January, 1953. During this terrifying night, the province of Zeeland on the southern coast of the North Sea was battered by one of the most terrible storms Europe has ever seen. A combination of 160 kilometers an hour winds, excessively high tides, and a powerful depression from the northwest sent the water up to an exceptional height.
Mankind has accomplished some absolutely incredible technical and technological feats. And we forget, when we talk about water, that water is so much more powerful.
You cannot tell it enough how the power is of the water, and you should be afraid of that.
Water shapes entire valleys and erodes everything in its path when it wants to. No matter how much technology you bring to it, it will always find a way. So it's up to you in the end not to get in its way.
The phenomenon of coastal flooding begins away from the coast. Tons of water are lifted up by gusts of wind to crash down on inhabited land. Because the Netherlands are located in a delta where rivers meet the sea, they are extremely vulnerable.
So if you think of the map of the North Sea and the wind from the north, you see that it goes into a funnel. So the water levels are pushed up, and this can lead to water levels that are 4 meters higher than the average sea level.
The wind drove a huge amount of water inland, and the water rose in the houses with incredible speed.
The water came so high that my father decided we should go on top of the roof. We know people who have saved their lives. They put out the tiles of the roof, and on the wooden construction they were floating.
In the early morning of the 1st of February 1953, the storm-stricken region of Zeeland woke up to utter devastation. The disastrous consequences of this high tide traumatized the entire country. There were more than 1,800 dead, 100,000 homeless, and 160,000 hectares of land flooded. Once again, Amsterdam was spared, but the country was forever marked. Despite the fact that these events were caused by natural phenomena, the consequences of the high water were linked to human construction. The Netherlands' ingenious network of dykes, built up over the years, broke in 89 places.
The important thing to understand is that protection is never total.
But if the Netherlands can never be totally protected, to what extent can Amsterdam be saved? After the Great Storm of 1953, the Dutch had no choice. They declared war on water. To wage this war, they set out a military strategy known as the Delta Plan. This plan described all the major works to be carried out to block the path of the water.
The fight against water is perhaps one of the major themes in the collective image that we have of the Netherlands.
Their main weapons were barrages, dams of unrivaled power and dykes that were stronger and higher than ever seen before. At every point of entry, the water would come up against the military force of these superstructures. The safety of the 18 million Dutch people who live behind them depends on it.
The most important thing was to be able to live here. First, they built the dykes to protect the fields, then they built the dykes to protect the people who lived behind them. So in 1953, they thought it was normal to spend up to 3% of GDP on these major projects.
This defense strategy took full effect in Zeeland, the region devastated by the storm of 1953. Seen from the sky, it looks like lace. The water is everywhere. To defend themselves against it, the Dutch erected some impressive dams. In 1979, a huge construction of earth and steel was created. The Oosterschedelkering, or the Eastern Scheldt Storm Surge Barrier, was the first superstructure to be built after the storm of 1953. It took 26 years for this unprecedented technological innovation to see the light of day. This 9-kilometer-long barrage, located between two islands, has 62 steel sliding doors, each weighing 480 tons. These 62 barriers, which separate the North Sea from the Eastern Scheldt River, have come down 27 times since the barrier went into operation. Each of the doors weighs the same as 15 heavy trucks, and they are lowered as soon as the swell exceeds 3 meters. On 27 occasions, they have fended off coastal surges like that seen in 1953.
It has protected our country from floods from the sea already for 2 generations. And so it will remain a very essential part of our flood defense strategy.
Once the south of the country was secured, this extraordinary plan to protect the country then turned to Amsterdam's big sister, Rotterdam, the country's economic capital. The biggest port in Europe, 80% of the city of Rotterdam is located below sea level. Rotterdam may have made its fortune from water, but at the same time, it risks perishing from it too. In the north and in the south, everywhere the water could come in had to be blocked to prevent flooding. The rivers are the enemy to be fought. And the first defense is the Haringvliet, a spectacular construction that regulates the waters of the Meuse and the Rhine, the two rivers that flow through Rotterdam. As soon as the water level gets too high and threatens to flood the city, the 17 openings in this dam are activated and the river water is dispatched into the North Sea. This 5-kilometre-long dam also serves as a 4-lane motorway.
The budget given over to this project and the money still granted to maintain it are quite phenomenal.
Since its implementation, the Delta Plan has served as a military strategy, constantly pushing the technological limits. And its centerpiece is the most prodigious superstructure ever seen in the world. The Maaslandkering, built in the 1990s. Its purpose is to protect the city from storms. Located at the entrance to the port of Rotterdam, this mobile dam protects more than 3.5 million inhabitants, along with the commercial activity of the 8th largest port in the world. This hydraulic structure was completed in 1997 and is the largest mobile structure in the world at 420 meters long, the equivalent to the length of 4 soccer fields end to end, and 20 meters high. Its designers have planned for all eventualities. To prevent such a system from breaking in the event of a major storm, they left a slight opening between the doors when they close. This breach prevents the dam from breaking when water flows in hard and fast.
So about 3 meters or 3 meters 50 above the mean sea level, and a storm surge with a certain force, wind force 11 or 12, then it is decided to close the dam.
Twice, this unrivaled example of technological prowess has proven its effectiveness. During the storm of November 2007 and the North Sea storm in January 2018, water levels reached record levels. The authorities decided to close the dam and managed to avoid the worst.
For the people living over there at around 3.2 meters above sea level, it's very important for the dam to close in time to avoid their houses being flooded.
For Europe's largest port and the country's largest city, the daily challenge is to keep the threat as far away as possible. In order to ensure the greatest possible protection from the water, the Maaslandkering has a partner construction with which it works in tandem. The Hartelkering barrier is located a little further inland. It works like a guillotine and wasn't included in the Delta Plan. But since the 1990s, climate predictions have made it indispensable. This impressive 98-meter-long mobile dike is mounted on 3 pillars. Each of its doors is suspended at a height of 14 meters above the canal, comparable to a 5-story building. Since 1997, the closing system has been used twice, simultaneously with the Maaslandkering barrier.
But this is a very gradual process, and we monitor this very closely, how this will evolve, because safety first.
Today, the Netherlands seem to be fully protected by its anti-flood weaponry. Just like Amsterdam, it is permanently monitored to keep the threat at bay. But behind their incredible technological prowess, the Dutch live with danger every day.
They have profoundly transformed their territory, and it is very tightly controlled. The aim is to have total control over the entire system, which no longer has anything natural about it. As such, we're not looking at a natural disaster. Rather, we're looking at a system failure that is due to this vision of having total control over nature.
In this artificial country, nature is like a machine in which humans control every cog.
And living in a machine like Holland means that you have to upgrade your machine every 30, 40, 50 years. 50 years ago, we thought that we were finished for the next 500 years. And now we know that we have to upgrade it, that the levees that we have, the polders that we have, are not enough to keep Holland dry for the next century.
Innovation and ingenuity can never stop here because there are so many dangers facing the Netherlands. In addition to rising water levels, river floods and storms, another major problem that is nibbling away at the Netherlands is one of coastal erosion. This is one of the first consequences of rising sea levels. The dunes subside and then disappear, and the disappearance of these mountains of sand is endangering the land behind the coast. Indeed, the dunes are the first line of protection against high waters. They act as natural ramparts. Without them, flooding would be unavoidable. And the Dutch have come up with a unique kind of vessel to reinforce them, the zand motor. The idea is simple. Sand is gathered from the seabed and then sprayed in a continuous stream back onto the coast. This strengthens the coastal dunes, which then protect the rest of the country. What makes the zand motor so unique is that it uses the energy of ocean currents to bring the sand to the dune and the natural movement of the tides to stabilize it. This amazing system, which is based on natural processes, does, however, have certain consequences for the environment.
It dredges the sand from the ocean floor, but the ocean floor is basin-shaped. So when you pump the sand from here, the sand on the coast collapses and falls back down to the seabed. And they keep trying to put it back here. But when you keep doing that, it keeps falling.
This process is currently being used in The Hague to protect the coastline. Some 20 million cubic meters have been pumped to create the equivalent of 256 soccer fields of dunes and beaches. This project is called the Dune Delta. The zand motor technology may eventually prove to be harmful to the country and its inhabitants. By constantly having to find solutions to the problem of living in inhospitable territory, the Dutch could end up having to leave this land.